Welcome to our channel Learning Math. In this video, we're going to solve the questions of probability and functions for official exam 2021, the first session of general science. Before starting together, for the continuity of our channel to support you by more and more information, please like, share and subscribe with a great appreciation for your support. Now let's start together. We have an air that contains 10 balls. 6 of them are blue and 4 are red. 2 balls are selected randomly and simultaneously from the air new. Consider the events. The event A, the 2 selected balls have the same color, and the event B, the 2 selected balls have different colors. Now in part 1, verify that the number of possible outcomes is 45. Since the 2 balls are selected simultaneously and at random, then we can say that the number of possible cases is combination 2 out of 10 in all. So it's 10 factorial over 2 factorial times 8 factorial. It gives us 45. Now show that the probability of the event A is 7 over 15 and deduce the probability of the event B. We should keep in mind that the event A, the 2 selected balls have the same color. They can be both red or both blue. So the probability of the event A is combination 2 out of 4 red over combination 2 out of 10. The total number of balls is 10. Plus the second case, combination 2 out of 6 blue balls over combination 2 out of 10. So it's equal 15 over 45 plus 6 over 45. It gives us 21 over 45. When we simplify it, we get 7 over 15. Now let's deduce together the probability of the event B. The event B says the 2 selected balls should have different colors. So we can say that P of B is equal P of A bar. Isn't it 1 minus P of A? So it's 1 minus 7 over 15 is equal to 8 over 15. Now in part B, a fair die numbered from 1 to 6 is rolled. If the die shows an even number, then the 2 balls are selected randomly and simultaneously from the air new. But if the die shows an odd number, then the 2 balls are selected randomly and successively with replacement from the air new. Now we have the events E, the die shows an even number, and the event F, the selected balls have the same color. In part 1, calculate P of F given E and verify that P of F intersection E equals 7 over 30. Well, if the die shows an even number, then 2 balls are selected simultaneously from the air U. They can be both blue or both red. So the probability of F given E is C2 4 out of over C2 10 combination 2 out of 10 plus combination 2 out of 6 over combination 2 out of 10. So it's equal 15 over 45 plus 6 over 45. It gives us 7 over 15. Now what about the probability of E and E intersection F? Note that the probability of the event E, if the outcome is an even number, we have 3 cases which are 2, 4, 6 out of the 6 cases. So the probability of the event E is 3 over 6, which is equal to 1 over 2. Now what's the probability of F intersection E? Isn't it probability of F given E times P of E? So it's 7 over 15 times 1 over 2. We have just calculated both probabilities. Then it's equal 7 over 30. As you see, they are asking us to show that it's 7 over 30. Now in part 2, verify that P of F intersection E bar is 13 over 15. By the same strategy, if the die shows us an odd number, what's the probability of the odd numbers, which is P of E bar? Aren't they 3 cases? 1, 3, 5 out of 6. So it's 3 over 6 equal half. This is the probability of E bar. What about P of F given E bar? The 2 balls should have the same color given that the die gives us an odd outcome. But we should pay attention here. When we have an odd outcome, the 2 balls are selected successively and with replacement. It can be the first blue and the second blue, 6 over 10 times 6 over 10, since here we have replacement. Plus the second case, the first can be red and the second can be red. The probability of red is 4 over 10 times 4 over 10 for the second case. So it gives us 52 over 100, which is equal to 13 over 25. Now we can say that P of F intersection E bar is P of F given E bar times P of E bar. We have just calculated both of them, so it's 13 over 25 times 1 over 2 is equal to 13 over 50. Now deduce P of F. Note that we have just calculated P of F intersection E and P of F intersection E bar. Can't we say that P of F is P of F intersection E plus P of F intersection E bar? So we have just to calculate them. So P of F intersection E plus P of F intersection E bar is 7 over 30 plus 13 over 50. It gives us 37 over 75. Now knowing that the two selected balls have the same color, calculate the probability that the die shows an even number. Here the event F is given since the two balls are given having the same color. So we should calculate the probability that the die shows an even number is P of E given F. Here we have the event F is given. Now how to calculate it? P of E given F is P of E intersection F over P of F. We have just calculated both of them. P of E given F, which is 7 over 30 over P of F, we have just calculated it 37 over 75. So it's equal to 35 over 74. Now let's start by the question of functions. Let G be a function defined on R as G of x equals x plus 1 exponential x minus 1. Verify that limit of G of x at minus infinity is minus 1 and determine limit of G of x as x tends to plus infinity. Limit of G of x as x tends to minus infinity is limit at minus infinity for x plus 1 exponential x minus 1. But here if you know something, minus infinity times 0 is indeterminate. We can transform this one into a fraction. It's the same as x plus 1 over exponential minus x minus 1. We just copy it. As you see, we have a fraction. Now we can apply L'Hopital rule. So it's limit at minus infinity to the derivative of the numerator, which is the derivative of x plus 1 equals 1, over the derivative of the denominator, which is minus exponential minus x. Minus 1, we just copy it. Well, what's the limit of 1 over minus exponential minus x? As x tends to minus infinity, minus x will tend to plus infinity. Then limit of exponential minus x will be plus infinity. But since we have here minus times plus minus, 1 over minus infinity, it will give us 0. Minus 1, sure we copy it, so it's 0 minus 1 equals minus 1. Now let's calculate limit of G of x as x tends to plus infinity. Here is so much easy. We can say that limit at plus infinity for x plus 1 is plus infinity. Also exponential x tends to plus infinity as x tends to plus infinity. So it's plus infinity minus 1 gives us plus infinity. Now copy and complete the following table of variations of G. Here as you see, x varies from minus infinity to minus 2 to plus infinity. G prime of x is negative on the interval minus infinity minus 2, and 0 over minus 2 is positive from minus 2 towards plus infinity. Now we should complete this table showing the variation of G of x. Since we have it given negative from minus infinity towards minus 2, then we can say that G of x is decreasing. Also, it's positive over minus 2 plus infinity, so we can say that G of x here is increasing. G is also continuous. Here, since G prime of minus 2 is 0, so we can say that here we have a local minimum. So G varies. At minus 2 is a local minimum. Now G varies from limit at minus infinity, which is minus 1, towards G of minus 2, which is minus exponential minus 2 minus 1. Here towards it will increase towards the limit at plus infinity of G of x, which is plus infinity. Now we have G of x is x plus 1 exponential x minus 1. We should calculate G of 0. which is 0 plus 1, exponential 0 minus 1. As you see, it's 1 minus 1, it gives us 0. Sure, since we have here exponential 0 is 1. Now verify that g of x is negative for all x negative and g of x is positive for all x positive. Note something, we have just proved that g of 0 equals 0, we should keep it in mind. Well, what happens for x is less than 0? There's something in particular for x less than minus 2. Isn't g of x strictly decreasing and continuous? It varies from minus 1 towards minus exponential minus 2 minus 1, which are all negative values. So we can say that here from minus infinity towards minus 2, g of x is negative. Well, what about for x less than 0? Here, between minus 2 and 0, g is continuous and strictly increasing from minus exponential minus 2 minus 1 towards 0. So for x less than 0, here g of x is less than g of 0, which is 0. Now we can say that in all, for x negative, g of x is negative. Well, what happens for x greater than 0? If we know something, isn't g of x here continuous and strictly increasing? So for every x greater than 0, g of x is greater than g of 0, which is 0. Then we can say that g of x is positive. Therefore, for x less than 0, g of x is negative, and for x greater than 0, g of x is positive. Now in part B, let f of x be a function defined over R by f of x equal x into exponential x minus 1. Denote by C its representative curve in the orthonormal system OIJ. As you see here, the unit is 1. And let D be the straight line with equation y equal minus x. Now in part A, determine limit of f of x at minus infinity and show that D is an asymptote to C. Let's start by A. Limit at minus infinity for f of x is limit at minus infinity for x into exponential x minus 1. At minus infinity, x tends to minus infinity, while exponential x tends to 0. Minus 1, sure, we copy it. So it's minus infinity into 0 minus 1, which is minus 1. Now minus times minus plus, so it's plus infinity. Now let's prove that D is an asymptote to C. To prove it, we should calculate limit at minus infinity for f of x minus x, which is the equation of D, and prove it 0. Note something here, minus times minus is plus, and here we can expand it, it will be x exponential x minus x times 1, which is x. We can cancel here x with x. This limit will be then equal to limit at minus infinity for x exponential x. Note something, when x tends to minus infinity, exponential x will tend to 0. Then here 0 times minus infinity, it will be indeterminate. How to solve in this case? We should transform it into a fraction and apply L'Hopital rule. How to transform it into a fraction? We can write it as x over exponential minus x instead of x. Well, now here we have it as a fraction. We can apply L'Hopital rule. The derivative of the numerator x is 1 and the derivative of the denominator e minus x is minus e minus x. Now limit at minus infinity for this fraction is 1 over minus exponential minus x. As x tends to minus infinity, minus x will tend to plus infinity. Then e minus x will tend to plus infinity. Now minus times plus is minus, so 1 over minus infinity is 0. We have proved the limit is 0, then we can say that D is an asymptote to C. Now determine limit of f of x as x tends to plus infinity and calculate f of 2. We should also prove that f prime of x equals g of x. How to solve that? Limit at plus infinity for f of x is limit at plus infinity for x into exponential x minus 1. Note that as x tends to plus infinity, exponential x will tend also to plus infinity. So the limit here will be plus infinity. What about f of 2? We can just replace x by 2. So f of 2 is equal to exponential into exponential 2 minus 1. Now we should prove that f prime of x is equal to g of x. How to prove it? Note something which is very important. F of x is in the form of u times v. U is x and v is exponential x minus 1. Can't we say that uv prime is equal to u prime v plus v prime u? U prime, the derivative of x, is 1 times v, which is exponential x minus 1, we just copy it, plus v prime u. V prime, the derivative of exponential x minus 1. Derivative of minus 1 is 0. What about the derivative of exponential x? It's exponential x times v, which is x, so it's x exponential x. Now we just solve them. So it's exponential x minus 1 plus x ex. As you see, we can take ex as a common factor. What remains for us? X plus 1, here x plus 1 into exponential x minus 1, we copy it. Isn't it the same as g of x? So we can deduce here that f prime of x is equal to g of x. Now they are asking us to set up the table of variations for the function f, and we should show that c has an inflection point I, which has the abscissa minus 2. Let's start together by the table of variations. We should keep in mind before putting this table something which is very important. We have just proved that f prime of x is equal to g of x. Why? Also, we have proved that g of x is positive for x positive. Can't we say in this case that f prime of x, which is equal to g of x, is positive for x positive? And also it will be negative for x negative, since f prime equals g. Also, we have proved that f prime of x equals g of x, then f prime of 0 will be equal to g of 0, which is 0. Now we can easily set up this table of variation. So f prime is negative from minus infinity towards 0 and positive from 0 towards plus infinity. Also f prime of 0 is 0. Now what about f of x? Sure, when f prime is negative, f will be decreasing. When it's positive, f will be increasing. Well, let's put the variations here. As you see, x varies from its limit at minus infinity, which is plus infinity, towards f of 0, which is 0. Then it will be increasing from f of 0, which is 0, towards its limit at plus infinity, which is also plus infinity. Now, how to prove that the point I that has an abscissa minus 2 is an inflection point? We should prove that the second derivative of f at this point is 0. Note that f double prime of minus 2 is equal to g prime of minus 2. We have it given 0, then f double prime of minus 2 is 0. So we can say that I is an inflection point for the curve C. Now draw D and C. How to draw them? Sure, first we should start. Sure, here we should start by the straight line D, which will be an asymptote. Now we start drawing the curve. As you see here, it will decrease towards 0 and then increase towards plus infinity. So here we have drawn the curve C and the straight line D. The equation f of x equal 1 has two real roots, alpha and beta, such that alpha is less than 0, less than beta. Now prove that integral for x exponential x dx is equal to x minus 1 into exponential x plus k, with k belongs to r. First, let's understand the given. F of x equals 1. Note that the straight line y equal 1 will intersect the curve C at 2 points. Here the roots are alpha and beta. So f of x equal 1 admits these two solutions. Alpha is less than 0, less than beta. Now let's start by integral for x ex dx. Note something, if we start for integration by parts. Let's take u equal x, then du will be equal to dx. Now if we take dv equals ex dx, can't we say that v is ex? Now what's the integral here? We can say that it's u v, so it's x ex minus integral v du, which is integral ex dx. You know that integral ex dx is ex plus k. So it's Ex minus Ex plus K, where K belongs to R, we can take Ex as a common factor, so it's X minus 1 times Ex plus K. Now in part B, let A of alpha be the area of the region bounded by the curve C, the straight line D, the lines x equal alpha and the y-axis. And show that A of alpha is equal to 1 plus alpha minus 1 over alpha units of area. Let's start by A. Well, there's something which is very important. Here we can say that this integral is integral from alpha to 0, as you see, since x varies from alpha towards 0, here the limit with y-axis, x varies from alpha to 0. The curve C is below the straight line D. Then we can say in this case that the area is integral from alpha to 0 for minus x, which is the equation of D, minus f of x dx. Now we have just to solve them, so it's minus x into Ex minus 1. We expand them. Note something that here minus times minus plus x times 1x minus x plus x will be cancelled. So it's integral for minus x Ex dx. Sure, x varies from alpha towards 0. We have just calculated that integral x Ex is x minus 1 Ex plus k. We can put it, since we have minus here, we copy it. Sure, we put the range from alpha towards 0. Now we can solve it. So it's minus 1 minus into alpha minus 1 E alpha. Now how to solve it? Here we can expand them. Now we should calculate it. If you know something, we have A of alpha in this case is equal to alpha E alpha minus E alpha plus 1. We have multiplied all by minus. Now we should prove that something which is very important for A of alpha. We should keep in mind that f of alpha is equal to 1. Here we can solve it. So alpha into E alpha minus 1 is equal to 1. We can expand them, then alpha E alpha minus alpha is equal to 1. In this case, we can say that alpha E alpha is equal to 1 plus alpha. Then E alpha is 1 over alpha. We move alpha to the other side. It's 1 over alpha plus alpha over alpha, which is 1. Well, now we just replace them by their values. We have just proved that A of alpha is equal to alpha E alpha. We can replace it here by 1 plus alpha minus E alpha. We can replace it by 1 over alpha plus 1. Plus 1, we copy it as you see the same. Now here it's equal to 1 plus alpha. Here we multiply them by minus, so it's minus 1 over alpha minus 1 plus 1. We copy it. Note that minus 1 plus 1 is cancelled. Therefore, we can say that the area of this region is A of alpha equals 1 plus alpha minus 1 over alpha. Thank you for watching. If you enjoyed this video, please like, share and subscribe.